This is a demonstration of my battery charge and discharge sequence, including timing for my patent-pending Energy Cell Regenerative System for electrically powered aircraft. What I've designed is an imaginary battery pack for a light sport aircraft, perhaps a heavy light sport aircraft. It's 14.4 kilowatts. It's divided into 4 modules. Each module is 120 volts. 2 of the modules are 40 amp hour capacity and the other 2 are 20 amp hour capacity. The foundation of the algorithm is that modules being used to fly the aircraft are being used sequentially, whereas modules being charged are charged simultaneously. We talked before about maybe being able to get 4,000 watts out of the turbine. Perhaps we need to add solar to get that, actually, solar wings. However, when it gets to the battery pack, let's say we're getting 2,000 watts. It can go twice through the channel, or with through the charger, or 2 turbines. So 2,000 watts and 2,000 watts are coming as we are flying the aircraft. We'll always be using more energy to fly the aircraft than we can capture to charge it. This isn't a perpetual motion device, but I believe that the way this is sequenced, the pack will run cooler and will be able to be much more efficient, because the energy that we're going to be using is coming from about here in the battery pack, 40%. Won't be balancing in flight. We do that in the hangar at the end of the day. So the foundation also of the timing is that I imagine that it would take 10 minutes to discharge a 40 amp hour pack at cruise, 120 volt 40 amp hour pack, and 15 minutes to charge it with our 2,000 watts. This we can think of as units, 10 units and 15 units, but it's just a baseline in order to be able to visualize how the sequence runs. However, for taking off, we need more power, so only at that time, or when we need it, we'll use 240 volts to take off to cruise. Then those batteries will be charged and we switch to flying 120 volts at cruise. The battery pack can be wired in parallel sequence. It's on our website, www.electronair.com. So let me demonstrate. What you'll see are green lights are when the battery module is discharging, flying the aircraft. Blue lights are when it is charging, the module is charging. So we're ready to take off. We put 240 volts to the motor through the controller, and off we go. I imagine it would take 5 minutes to get to 2,000 feet altitude. At that time, the charger begins charging, and we fly on module number 3 for 5 minutes. 1 and 2 are still charging. It took 7.5 minutes, while module 4 is flying the aircraft for how long? 10 minutes, that's what we said. And then the sequence begins to cycle normally from here on. These batteries now charge simultaneously, while module number 1 is flown for 10 minutes. This will take 7.5 minutes to charge. That takes 15 minutes to charge. So what you'll see is this will go out. 7.5 minutes have elapsed from the 10 and from the 15. Number 1 is depleted, and now we begin flying on number 2. When number 4 is charged, we start charging numbers 1 and 2 at the same time, and back to flying on number 3. So that's the sequence. That's how it would work optimally. The other testing that I've been doing, and that I haven't really arrived at a conclusion, but I think is intriguing, is what if we were able to speed up the sequence and fly the aircraft with that sort of configuration. I think it has some merit. I think it should be studied, and I think that the timing, therefore, is not just the ratios, but how fast the battery pack is rotated.